Hello everybody, this is Cameron Snow with Danomics.com. So in this video, I briefly want to go over exactly what is petrophysics and log analysis and what it means to the professional when you hear these two terms. And also I want to cover a little bit of the differences here because you'll hear people talk about petrophysics and log analysis, and a lot of times those terms are used interchangeably, but a lot of times specialists in the field like to draw a bit of a distinction between the two. So that's what we're going to be talking about in this video. So to start off, what is petrophysics? So petrophysics is the practice of using well log data, core, and other complementary data to understand the rock and fluid properties within a reservoir. So, if you think about after you drill a well, the first questions you're going to ask are, is there oil and gas in this well? What are the storage properties of this well? Will we be able to flow the oil and gas that we may have discovered in this well to surface? And so that is what the discipline of petrophysics is concerned with. And so, there's a lot of kind of standard petrophysical properties that'll be calculated, and we're going to cover all of those in detail as we go through the educational component of these videos. But I just want to give you a list of those now. So, a lot of times you start off, you calculate your clay volume, so, what's the proportion of, sand to shell or limestone to shell in a rock. Then you calculate the total organic carbon, is this potentially a source rock? If so, is it mature? Could the TOC content be affecting porosity, things like that. Then we go and we calculate the porosity. So what's the storage volume of a rock? So, porosity is the space that sits in between the grains in a rock, and that's where the oil and gas and water are stored. So we want to calculate that so we can get a volumetric. Then we want to calculate the saturation, and normally we refer to this as the water saturation, because a lot of times we can only tell if something is hydrocarbon or water, and it's difficult to determine the phase without other testing capabilities. Then we want to look a little bit at things like permeability. What's the capability of this rock to flow? It's not uncommon to find hydrocarbons that are very, very difficult to move. So if you think about the shale revolution, we always knew there was oil and gas in shales. We just didn't know how to get it out for a long time, and that's because of the permeability. So that's why that's an important property that we calculate. In the future, we're going to look at volumetrics. So, we're going to take the combination of the porosity and the saturation, and we're going to look at drainage area, and then we're going to turn that into a volumetrics estimates. But petrophysics can also encompass, a lot of adjacent disciplines. Things like geomechanics. What's the brittleness of your rock? What's the shear log response telling us about our ability to frack this rock? What's the pore pressure? Is it a normally pressured system? Is it an overpressured system, etc. So what is it that a petrophysicist does in their day-to-day work? Well, they interpret well log data, and they do this to provide a quantitative estimate of reservoir properties. And I want to put an emphasis on the word quantitative. And the reason why is pretty much every subsurface professional should be able to look at a well log and provide a qualitative estimate. So you look at your well log and you say, oh, well, my gamma ray is going to to a lower value. I've got good porosity, and I see my resistivity is going up. That tells me that there's hydrocarbons. I see my resistivity going down in the same interval. That tells me I've entered a water leg. That's a qualitative analysis. Petrophysics is concerned not only about the qualitative, but also about quantifying those values. So, okay, the rock has, quote, good porosity. What does that mean? Is that 8% or 10% or 15% porosity? It's about determining the saturation. Are we sitting close to irreducible saturation? How far above the fluid contacts are we, etc. So that is what petrophysics is concerned with, and petrophysics is a very quantitative discipline. So petrophysicists often work with core data, and when you're working with core data, a lot of times you need to coordinate and supervise the acquisition of that core, and then the data acquisition program on that core. Once you've got the core back in the warehouse, back in the core lab. So as a petrophysicist in a company, it's often your job to make recommendations on why we're collecting core, how much core needs to be collected, over what intervals, and to make the business case for that. We don't collect core just to learn more about the rocks. We want to maximize our knowledge from that core, and we need to make sure that there's a business case for it. And the petrophysicist is often tasked with that. And the other common role for petrophysicists is to design the logging programs for wells. Now, a lot of times now we're horizontally drilling wells, and you either just have a gamma ray or gamma ray and resistivity in those horizontal wells because you either don't want or don't need an expensive piece of logging kit down the hole. But for pilot wells, for exploration wells, we still run, a whole suite of logs, things that are often very specialized. And it's up to the petrophysicist to balance cost with business needs, to work with the service companies to try and find the best solution, and while at the same time making sure the company doesn't get sold on solutions that it doesn't need. So those are some of the most common tasks that petrophysicists do. I will say that in my experience as a petro, I probably spend 75% of my time concerned with that first one, so looking at well logs, interpreting well logs, and then less time on the latter two. But for some people, that experience is entirely switched. Um, but really, as a petrophysicist, you should be working with your geologists and engineers and the drillers to help them understand how reservoir properties will affect your operational and business decisions. And this may sound a bit out there too and a bit vague, but the petrophysicist has a seat at the table, and for good reason. So for example, if you're talking to your drilling engineer and you're drilling through a formation that is potentially overpressured. The petrophysicist should be involved in those overpressure calculations and looking at what's driving that. If you're talking to your completion engineers, your petrophysicist should be making the case for why we should, let's say, run shear logs so we can better determine how we can frack a reservoir. We're working with reservoir engineers to help them, calibrate their storage properties so they can determine if there's enough oil and gas in a particular drilling location to justify, the economics of drilling. So the petrophysicist really should have a role at the table in most companies. And if you are working as a petrophysicist and you don't have that seat at the table, you need to start advocating for it. So, kind of the other side of the coin of petrophysics is log analysis. And a lot of people use the term petrophysics and log analysis interchangeably, and that's because a lot of times they are interchangeable. But really, log analysis is just focused on the application of petrophysical equations to well log data. So this work is often done by non-petrophysicists. So a lot of times you'll have geologists and engineers that are perfectly capable of reading and using these equations to get a petrophysical property out. Um, and a lot of times I'll say what really separates the petrophysicist from the non-petrophysicist and what separates petrophysics from log analysis is the calibration of the analysis. So, a non-petrophysicist, they'll often apply the equation, but they won't, necessarily have the understanding to be able to, properly modify those parameters to calibrate themselves to core data or to fluid data. Um, and this has led to a situation where many petrophysicists use the term log analysis a bit disparagingly. However, log analysis is the most commonly practiced subdiscipline in petrophysics. So, it shouldn't be used negatively. It is a very valid subdiscipline and something that people do quite often. So finally, just to wrap this up, just to summarize the differences here, what's the difference between petrophysics and log analysis? So petrophysics is performed by definition by an expert petrophysicist. It is a very quantitative interpretation of well log properties. It is often calibrated to core, fluid, and production data. And in petrophysics, we often do a very deep dive on a very limited set of wells, for example. So you go in and you do a top tier analysis on a very small data set. Log analysis, on the other hand, it can be performed by a petrophysicist, but it can also equally be performed by a geoscientist or an engineer. Um, it is, often a quantitative interpretation of well log properties, but it's often an uncalibrated or only loosely calibrated analysis. So maybe you're doing your log analysis without core to calibrate to. Maybe you're doing your log analysis and you know that a well produces, so you know that it has to have net pay in there, but you've not calculated your saturation, you've not measured it in a lab, you're not calibrated to that. So it's often somewhat calibrated, but not as strictly calibrated as a true petrophysical analysis. And log analysis, just because of who is applying it, it often gets applied to very large data sets. So, geologists may go out and correlate thousands of wells, and then they apply a petrophysical equation across a large data set. And so it's often a analysis that's, a mile wide and an inch deep, so to say, whereas the petrophysicist often goes a mile deep and an inch wide. So those are the differences between petrophysics and log analysis. Um, I know this video, didn't really teach you any new techniques, but I wanted, for those of you who weren't familiar with the term petrophysics or log analysis, to really get a feel for how I'm using those terms as we're moving forward and how other people use those terms. I hope this video was useful to you, and we are going to be posting a lot more content over the coming weeks, so please stay tuned in for more. Thank you. Goodbye.